So in this last video for chapter 16, we're going to kind of continue the same things we've been doing the last couple of videos. We're talking about confidence intervals still, margin of error, and again, just to kind of recap the confidence interval idea. We take a sample proportion. We're going to denote that by p hat, and we want to estimate where is the population proportion p going to be. And so we can assume that it's going to be somewhere near our sample proportion as long as we follow all the guidelines and rules that we should when we're collecting data. So go out some distance away from p hat. We call that the margin of error. We talked a lot about that in the last video. And we then, depending on how far out we want to go, but let's say we go approximately 2 standard deviations away, then we can assume with 95% confidence that p will be in that interval somewhere. So somewhere between these two numbers, whatever those are. So like we mentioned in the first video in this chapter, standard deviation of p hat is the square root of p times q over n. P is the population proportion, q is 1 minus p, and then n is the sample size. So as you can imagine, the larger the sample size, so that means that n would be going up. If n goes up, this fraction will go down, the square root will go down, and so the standard deviation will go down, or the standard deviation decreases. As n goes up, standard deviation will go down because the bottom of this fraction will be getting bigger, the fraction will be getting smaller, so standard deviation is getting smaller. And vice versa, if the sample size gets smaller, then standard deviation increases. So we can quantify this. If we multiply n by 4, what would happen to the standard deviation? So the 4 is under the square root. So if we solve this, then the square root of 4 is going to be 2. So that means that we are dividing standard deviation by 2. Standard deviation, sorry, divide standard deviation by the square root of 4, which is 2. So we're dividing the standard deviation by 2. If we multiply n by 9, we would divide the standard deviation by 3. Or if we multiply n by 6, then we're dividing standard deviation by square root of 6, whatever it is. So that's how that relationship works. But more likely, if we want to reduce standard deviation, then we can figure out what sample size we need. So if we want to reduce standard deviation by a factor of 10, then we need to multiply n by 10 squared, or 100. So that's how that relationship works. There's an inverse square relationship between n and standard deviation. So it's inverse because n is on the bottom, standard deviation is on the top on this side, and it's square because n is under the square root, standard deviation is not. So so that's how that relationship works. And we'll have kind of abstract problems where it'll say if you multiply n by this much, how much is standard deviation changed by, or if you want to reduce standard deviation by something, some factor, what sample size do you need? So we could put numbers with this. And say if n is 100 and you want to divide standard deviation by 2, what sample size do you need? Well, you need a sample size of 400 instead of 100, so that kind of thing. Okay, so let's look at another of these sample size examples. Like I said in the last video, if you practice these enough, you can do these pretty quickly and maybe not even need to write anything down because it's the same process through the calculator. So this one says 65% believe global warming is due to human activity. What sample size is needed to obtain a 95% confidence interval with margin of error less than or equal to 2%? Now, don't worry about the plus or minus. That's really just talking about on either side of the p hat. We can treat this the same way as we did the last one. So, so write our margin of error formula. And like I think I've probably said in other videos, if you want to memorize formulas, just write them down every time you're going to use them before you fill anything in, and then it gets pretty easy to memorize them. So Margin of error is 2%, so 0.02. Z star, now we talked about how to find the Z star in the last video, so I won't go through that again. Z star for 95% is 1.96. And if you need to figure out how to get that, again, just go back and watch the last video and I go through that in detail. Then square root of p hat is 0.65. Q hat is 1 minus 0.65, so 0.35. And then we are looking for n. So anytime you see what sample size is needed, that tells you that you're looking for n. So now we're going to solve this in the same way that we did the last one. So we're going to divide both sides by 1.96. So divide 1.96. We want to isolate the square root first. And so we get 0.010204. Now remember, it's easy to get rounding errors. We don't want to just do 0.01 or even 0.010, which obviously doesn't change anything, but keep 5 or 6 digits after the decimal when you're doing these, because otherwise you are likely to get rounding errors. And then we'll multiply the 0.65 times the 0.35, and we get 0.2275 over n. So now we have the square root isolated. We can square both sides. And 0.010204 squared. And again, we get the e-4 at the end of the answer if you're using the TI calculator. And so again, all that means is it's scientific notation. So it's that number that it gives times 10 to the -4. So we need to move the decimal 4 places to the left, which means we're going to have 3 zeros. So 0, 0, 0, 1, 0, 4, 1. And then the square root and the square cancel each other out. So we have 0.2275 over n. We will cross multiply and we get 0.000104 n equals 0.2275. Divide by 0.000104 and we get 2184.9. And it doesn't really matter. It doesn't matter what the decimal is. And you'll never get an integer. It's just not going to happen because you have the square and the square root, and so it's not going to happen. Now remember, and obviously with this one, you would not be tempted to round this one down, but we always round up because we want the margin of error to be less than 2%. You can plug in 2184 and for n and figure out what that margin of error would be, and it would be more than 2%. So just barely, but it would be more than 2%. So always round up on these sample size, calculating the sample size type problems. And again, the same steps. If you go back and watch the example that I did in the last one, you can see it's literally the same steps, no different. So just practice these a couple of times and they should become pretty easily after that. Okay, so the last example is actually finding a confidence interval. And we're going to do this, we've kind of done this manually on a couple of other examples earlier in the chapter. We're going to do this one completely on the calculator, and it's very easy. A company wants to estimate the proportion of satisfied customers. Out of 250 surveyed, 175 said they are satisfied. Now before we do this, let's talk about the conditions. So the first condition was independence, and we can probably assume independence. If you're satisfied, it doesn't really affect whether another random person is satisfied or not. So we can assume independence, even though it doesn't say that it's a random sample. 2 is the 10% condition. We can probably assume that because 10%, 250 is 10% of 2,500. So does this company have more than 2,500 customers? Probably safe to assume that. No reason to not assume that. And then the success failure condition, we need n times p to be well, really in this case, we just need this to be more than 10 and then the difference to be more than 10. So number of successes is 175, and then number of failures is 250 minus 175, which is more, both of these are more than 10. So don't even really worry about don't even know what that is. We know it's more than 10. So all of the conditions are met, so we can find a confidence interval. And again, all of these problems are categorical variables, but the way you can know it, first of all, it says proportion. Anytime you see proportion, that tells you it's a categorical variable. And this is a binary choice. There are only two categories, either satisfied or unsatisfied. So that will help later, especially when you get to the test and you have some that are categorical variables, some that are quantitative variables. So you want to make sure that you can easily identify what type of variable you are working with, even though all the ones in this chapter are categorical, all the ones in the next chapter would be quantitative. Make sure that you're paying attention to that and can identify how, what type of variable you're working with. So now the conditions are met. And you'll have problems where it asks you specifically which conditions may be met. If we're just finding a confidence interval, it's probably not that important because they're going to be met. So on the TI-83, TI-84 calculator, you are going to go to the stat button and then go over to test. So you have along the top, you have edit, calc, test. You're going to go over to test, and we're going to, you have to scroll down and pick one prop Z interval. If you remember, I think it's on the second video, we call these confidence intervals one proportion Z intervals. So one prop Z interval. And then you're going to see you have X, you have N, you have C level, and then calculate. So the X is just the number of successes, in this case 75 or 175. N is the sample size, in this case 250. And then the C level is, of course, 0.90, and then just hit calculate. And when you do that, you get 0.652 and 0.748. So very easy. It's important. And the reason I didn't show this in the beginning is because it's important to get the idea and kind of what we're trying to accomplish here. I think if you just learn how to do this, you don't really understand what is going on, and it's pretty important. A lot of the questions are more conceptual, so it's not just that you need to memorize how to do this on the calculator. You need to be able to interpret what this is telling you, which is really important for the whole class. You need to be able to interpret these numbers. The whole purpose of the class is to get you comfortable with data and interpreting data, and how numbers look, how different data sets look compared to each other, and that kind of thing. So just plugging things in the calculator, getting numbers means nothing if you don't know what it means. So all right, so that's it for this chapter. We'll pick it up in the next chapter.